Good day everyone! Welcome back to my channel. Our most essential learning competency for today is illustrating the domain and range of the inverse of trigonometric functions. The inverse of the sine function with domain from -1 to +1 and range from -pi/2 to pi/2 is defined by y is equal to arc sine x if and only if sine y is equal to x. What does that mean? Suppose we have here sine y is equal to 1. We know that y here is an angle. To get the value of this angle, we get its inverse, and that is arc sine of 1. Or in symbol, this one is arc sine 1. Again, this one is read as arc sine 1. If we are getting the angle, the value of the angle, we have to get its inverse. Now, we have to look at the angles in the unit circle. Of course, if we have sine 1 there, it can be found where? In angle pi/2, or of course 90 degrees. Now, the inverse of the cosine function with domain from -1 to +1 and range from 0 to pi is defined by y equals arc cosine x if and only if cosine y is equal to x. Same as, of course, for cosine. If we have cosine of y is equal to 0, to solve for y, we get the inverse of this. This one is arc cosine 0. Or in symbol, this is arc cosine 0. We look for the value of y. Remember that y is an angle in which the cosine function is equal to 0. So, cosine 0 is, of course, we have what degrees? That is 90 degrees. And, of course, 270 degrees. Okay, or that is pi/2 and 3 pi/2. That's in radian. Okay, let us now evaluate the inverse, of course, of the trigonometric functions using the domain and the range. We have here arc sine of 0. 0 is in between -1 to +1. Of course, we know that this one is theta. To solve for theta, we get the value of arc sine 0. We have to look for the angle in which, of course, the value of the sine function is 0 degrees. Using the unit circle, the special angles in the unit circle. So we can say that this one is 0 degrees or 360 or 0 to pi. Now, it says here that the range is from -pi/2 to +pi/2 only. If we'll locate it, this one is -pi/2 and this one is +pi/2. So therefore, we only need, of course, 0 degrees. So theta here, or the range here, is 0 degrees. Example number 2. We have arc sine 1/2. For arc sine 1/2, this one is equal to theta. So we look for, of course, the value of sine function in which that is equal to 1/2. What is the value of that angle that is equal to 1/2? So if we'll try to draw it, this one is, of course, the unit circle. This one is 1/2. So this is 1/2 and then 1/2. Y is equal to 1/2. So this is 30 degrees and this one is 330 degrees. But of course, it says there that our range is from -pi/2 to only. We have negative pi over 2 to positive pi over 2 only. So therefore, we have of course 30 degrees or pi over. Example 3, arc sine negative 1. We know that this one is equivalent to theta. Theta here is arc sine negative 1. We have to look for the value of the angle in which sine is equal to negative 1. If we'll try to draw it, this one is 270 and this is negative 1. Sine here is negative 1. So therefore, theta is equivalent to 270 degrees. Now, question, does it include in this range, negative pi over 2, pi over 2? So this one is negative pi over 2. Therefore, theta here is negative pi over 2. Now, for number 4, we have arc sine of 2 is equal to theta. We know that 2 is not part of the domain because our domain is negative 1 to positive 1 only. Therefore, our theta here is, of course, cannot be determined because 2 here is, of course, undefined. Arc sine 2 is undefined. Therefore, theta cannot be determined. Let's evaluate now the inverse of cosine. We have here cosine, arc cosine of 0 is equal to theta. Take note that 0 is in between negative 1 to positive 1. Our range this time is 0 to pi. So if we'll graph it, this one is 0, this one is pi. Using, of course, the unit circle, this one is 0, and this one is pi. So we have to look for the value of the angle in which cosine is 0. So 0 cosine, and that is equivalent, of course, here. This one is pi over 2. So the value of theta is pi over 2 or 90 degrees. What about number 2? We have arc cosine negative 3 over 2. So this one is equivalent to theta. Negative 3 over 2 is not included in the domain. Therefore, this one, arc cosine negative 3 over 2 is, of course, undefined. Therefore, theta cannot be determined. Example 3, we have arc cosine negative square root of 2 over 2 equals, of course, theta. We know that negative square root of 2 over 2 is approximately negative 0.7. And that is included in the domain negative 1 to positive 1. So we have to look for the value of this angle in which cosine is negative square root of 2 over 2. So if we'll use the unit circle again, we know that this one is 45 by 45 negative, so it can be here and here. This one is 45 by 45 negative square root of 2 over 2. This is negative square root of 2 over 2. And we have here 135 and 225 degrees. But we are looking for only angle from 0 to pi. So therefore, this one is equivalent to 135 degrees, or that is 3 pi over 4. Number 4. For number 4, we have here cosine, arc cosine 1/2. This one is theta. So we look for the value of the angle in which cosine is equivalent to 1/2. So if I will be illustrating it using the unit circle again, this one is the unit circle. This time 1/2. So this one is 1/2. And this one is also 1/2. So cosine of this is 60 degrees. And this one is 300 degrees. Of course, again, we need to consider the range, which is from 0 to pi. Therefore, theta is only 60 degrees, or that is equivalent to pi over 3. Let us now go to the inverse of the tangent function. The inverse of the tangent function with domain, the set of real numbers in range from negative pi over 2 to positive pi over 2 is defined by y equals arctangent x if and only if tangent of y is equal to x. Let us evaluate this one. Number 1. We have arctan of 0 is equal, of course, to theta. We know that theta is equivalent to arctan of 0. Now, we have to look for the value of the angle in which tangent is equal to 0. We know that tangent is sine over cosine. So, sine here is 0, and then cosine is, of course, 1. So, therefore, that's 0 over 1. So, theta is equivalent to 0 degrees, or, of course, 0 pi. Now, take note that our range is from negative pi over 2 to positive pi over. Example number 2, arctangent negative square root of 3. Negative square root of 3 is, of course, in between negative 1 to positive 1. So this one is possible. We can get a value for theta. We know that this is equivalent to theta. Theta is equal to arctangent negative square root of 3. We have to look for the value of the angle in which tangent is negative square root of 3. So, since this one is negative, I can conclude that it can be in quadrant 2 or in quadrant 4 because the tangent function here is negative. Now, our range is from negative pi over 2 up to, of course, pi over 2 only. So, if we'll try to identify it, this one is negative pi over 2 and this one is pi over 2, meaning this is not possible. So, therefore, our theta is, we have to look for the value of this. This one is, okay, so this is 1/2 and this one is negative square root of 3 over 2. So if we'll get the tangent of this, tangent of this angle is, of course, multiple of 60, so that will be equal to 300 degrees. Okay, so this is sine square root of 3 over 2. Cosine 1/2, cancelled, it's negative square root of 3. And this 300 degrees is in between negative pi over 2 and pi over 2. So therefore, I can say that this one is negative pi over 3. Or this is negative 60 degrees. Okay, let us go to number 3 now. Arctangent negative square root of 3 over 3. Again, that is possible because it is in between negative 1 to positive 1. This is theta. So we look for the value of theta in which tangent is equivalent to negative square root of 3 over 3. So if I will be locating it, again, our tangent is negative, so it can be in quadrant 2 or quadrant 4. This one is not possible anymore. So this is, of course, the quadrant 4. And this is the angle. So this one is 1/2 negative, and this one is square root of 3 over 2. So if I will be representing it in degrees, this one is negative 30 degrees. Or negative pi over 6. So, tangent here is, of course, negative square root of 3 over 3. That is sine over cosine. So, therefore, theta is negative pi over. Example number 4. We have arctan 1 equals, of course, theta. So, 1 is included in the domain, negative 1 to positive 1. So, therefore, we can get a value of theta. arc tan 1. So we have to look for the value of the angle in which the tangent function is equal to 1. So if I will be illustrating it again, this one is quadrant 1 and quadrant 3. Because the tangent function in quadrant 1 and in quadrant 2 is negative. So therefore, I will be choosing quadrant 1 because it is from negative pi over 2 up to positive pi over 2 using of course the unit circle 1. So therefore this one is 45 degrees. Why? Because we know that the sine and the cosine function in 45 degrees are both equal to square root of 2 over 2. So square root of 2 over 2 over square root of 2 over 2 is equal to 1, and that is equivalent to 45 degrees or pi over. For the inverse of the three remaining functions, we have the inverse of the cotangent function with domain, the set of real numbers in range 0 to pi is defined by y equals arc cotangent of x if and only if cotangent y is equal to x. The inverse of the second function with domain negative infinity up to negative 1, union 1 up to positive infinity, and range from 0 to pi over 2, union pi over 2 to pi is defined by y equals arc secant x if and only if secant of y is equal to, of course, x. The inverse of the cosecant function with domain negative infinity up to negative 1. Union 1 up to positive infinity and range na negative pi over 2 to 0. Union 0 to pi over 2 is defined by y equals arc cosecant x if and only if cosecant of y is equal to x.